Is the screen visible?
Yes, sir.
Okay. So, good morning to one and all. We have started with the last part of our first unit, which is the notches and weirs part. Okay. In this, we have studied in the last two lectures what are notches, what is a weir. Okay. Then we have studied the classification of notches. Then we have studied the classifications of weirs. Okay. Then proceeding further, we started with the derivation of discharge over a rectangular notch or a weir. Then we studied discharge over a triangular notch or a weir, and we solved numericals on both these discharges. Today we are going to start with discharge over trapezoidal notch or a weir. Okay, and I have sent you the notes of of today's lecture on Sunday itself. I hope everyone has read those notes. Okay, or at least cursory glanced it so that we can okay. So is the image visible to all? Discharge over a trapezoidal notch or weir?
Yes, sir.
Just 40 students have joined. I'll just tell the students to join. So we have studied discharge over a rectangular notch or weir, and then we have studied discharge over a triangular notch or a weir. Today we'll start with discharge over a trapezoidal notch or a weir. So similar to those, we'll find out the formula for discharge, which is going to take place over the crest of this trapezoidal notch. Okay, we'll find out the formula and then we'll solve numericals on it. So consider a trapezoidal notch or a weir, which is a combination of a rectangular and triangular notch or weir, which is given in the figure below. Okay, and as this trapezoidal notch or a weir is a combination of rectangular and triangular notch, the discharge over such a notch or a weir will be the sum of discharges over the rectangular and triangular notches or weirs. So what this means is, if you consider a trapezoidal notch, okay, now what I can do is I can divide this trapezoidal notch into three parts. I'll call this A, B, and C part. Now, if you see the middle B part, it is nothing but a rectangular notch. Okay, it is nothing but a rectangular notch. So for this B part of the notch, I can use the formula for rectangular notch, discharge over a rectangular notch. Now, this was about the B part. Now, if I take A part and C part and combine those both, I'll get a triangle. Okay, what I have done here is I have combined the A part and the C part, and when I combine this A and C part, what I get is a triangle. Now for this part, I will use the formula for discharge over a triangular notch or weir. Okay, and then I will add both this discharge over rectangular notch plus discharge over a triangular notch, and after I add both this, I will get the formula for discharge over a trapezoidal notch or weir. Let us see how it is done. What should be done here is I will divide. Okay, I will divide this trapezoidal notch into three parts. Now this middle B part, I will use the formula for rectangular notch, and the A part and C part, I will combine these both parts. Now you can see A is a right angle triangle, C is also a right angle triangle, C part. Now if I combine both this, I will get a whole triangle. Okay, and for this part I will use the formula for discharge over a triangular notch or a weir. So let us see how it is done. I'll proceed. So let h be the height of water over the notch. So h, capital H, is the water level above the crest of the notch. Let capital L be the length of the rectangular portion or crest of the notch. Okay, so this L is the length of the crest. Next, let CD1 be the coefficient of discharge for the rectangular portion, and let CD2 be the coefficient of discharge for the triangular portion. आता आपलं रेक्टँग्युलर पोर्शन आणि ट्रायंग्युलर पोर्शन मध्ये आपण डिफरन्शिएट करणार आहे. And a rectangular notch has a different coefficient of discharge. A triangular notch has a different coefficient of discharge. So for both the different portions, I will consider the different coefficient of discharges. Okay, proceeding. Now, the discharge through the rectangular portion BCFE. म्हणजे कुठला पार्ट हा BCFE. So for this part, I'll just show it in a hashed portion. Now for this part, which is a rectangular portion, the discharge will be given by the formula Q1, that is discharge through the rectangular portion, is equal to the formula for discharge through the rectangular notch. हा formula कुठला आहे? Discharge through the rectangular notch, 2/3 CD L square root of 2G into H raised to 3/2. ओके, आणि इथं रेक्टँग्युलर पोर्शन आहे त्याच्यामुळे त्याचं कोएफिशियंट ऑफ डिस्चार्ज काय आहे? CD1. Similarly, I will find out the discharge through the triangular portion. So the discharge through two triangular notches ABE and FCD. Okay, ABE. Okay, so this is the first portion. I'll show it in the hatched part, and this is the second portion FCD. Okay, so the discharge through the two triangular notches ABE and FCD is equal to the discharge through a single triangular notch of angle theta, and is given by. Okay, so here we will use the formula for discharge through the triangular notch or weir, which is Q2 is equal to 8/15 CD square root of 2G into tan theta by 2 into H raised to 5/2. Okay, where CD2 is the discharge coefficient of discharge through the triangular portion. Okay, have you understood up to here?
Yes, sir.
Sir, so of triangle, right angle triangle ABE, angle is theta by 2. Okay. Then for right angle triangle FCD, the angle is theta by 2. When I combined both this right angle triangle, I will get, okay, here BC, here A I will get, here D, here I will get E F. I combine this, and theta by 2 addition of both, I will get the single angle theta. Okay. So when I get such an angle of a triangular portion, I will directly use the formula for discharge through a triangular notch. Okay. So for the middle rectangular portion, I have got the formula for discharge. And for the remaining triangular portion, I have got the formula for discharge. Now what I'm going to do is, I'm going to add both these. So therefore the discharge through the entire trapezoidal notch or weir A, B, C, D, A. Okay, for this entire trapezoidal notch, okay, the discharge Q will be equal to discharge through the rectangular portion plus discharge through the triangular portion. Okay, just I will do the addition of rectangular formula plus triangular formula. So the formula for trapezoidal notch or weir, okay, it is the easiest. फक्त काय करायचं आहे, रेक्टँग्युलर नॉच प्लस ट्रॅपेझॉइडल नॉच चा जो डिस्चार्जचा फॉर्म्युला आहे तो काय करायचा आहे आपल्याला, ऍड करायचा आहे. Then we'll get the discharge over a trapezoidal notch or weir. Understood? Any doubts? Any questions? Okay, should we proceed?
Yes, sir.
Okay, so we'll directly go to the numericals on trapezoidal notches or weirs. Okay, there is just one question on trapezoidal notch and weir. Okay, so the question is, find the discharge through a trapezoidal notch which is 1.2 meter wide at the top and 0.5 meter at the bottom and is 0.4 meter in height. The head of water on the notch is 0.3 meter. Assume coefficient of discharge for rectangular portion is 0.62, while for triangular portion it is 0.60. Okay. Okay. So let us see what all is given. A trapezoidal notch is there. Okay. And we have to find the discharge which is taking place over this trapezoidal notch. Now, the dimensions of the trapezoidal notch are given to us. Okay, so the top width of the trapezoidal notch is 1.2 meter. The bottom width is 0.5 meter. Okay, then the total height of this notch, it is 0.4 meter. Okay, but we do not want the total height. Okay, we will require it for some other purpose. Important to us is head of water on the notch, which is 0.3 meters. Okay. Now, What we are going to do here is we are going to divide this trapezoidal notch into rectangular and triangular portion. Okay, so I'll just A, B, C, D, E, and F. Okay, now for this portion B, C, E, F. Okay, so for rectangular portion B, C, E, F, what are the dimensions that we get? Length of the notch or the crest of the notch is 0.5 meter. That is the bottom width. Bottom width म्हणजेच काय इथं तुमची क्रेस्टची length. It is 0.5 meter. Then the height of water above the notch or above the crest of the notch काय दिलेलं आहे? इथं head of water दिले 0.3 meter. So head of water is 0.3 meters. Okay, आणि rectangle साठी coefficient of discharge दिलेला आहे 0.62. Directly you can find out discharge through the rectangular portion, which I will denote it as Q1. So Q1 is 2 by 3 into CD1 into L into square root of 2G into H raised to 3 by 2. इथं L ची व्हॅल्यू 0.5 मीटर, CD ची व्हॅल्यू 0.62, capital H ची value 0.3 and G ची value, as we all know, it is 9.81. So what is the value or what is the answer for discharge through rectangular portion? What is the answer? Anyone?
Zero point 1505.
0.1504,
1504, sir.
0.150.
meter cube per second. Okay. Now write this down in your notebook. Okay, so that we can rub this and we can solve for triangular portion next. So discharge through the rectangular portion is 0.1504 meter cube per second. So we have found out the discharge through this middle portion. Okay, so are you finished?
Yes, sir.
Done, sir.
Okay, so just let me rub this now. Now for triangular portion. Now this is a little bit tricky than the rectangular portion. ओके, इथं आपण काय करणार, राईट अँगल ट्रायंगल एबीएफ आणि राईट अँगल ट्रायंगल ईसीडी आपण कंबाईन करणार. ओके, आता कंबाईन केले म्हणल्यावर हे टॉप विड्थ किती येणार आहे कोण सांगू शकतंय? जस्ट बाय युजिंग कॉमन सेन्स और बेसिक मॅथ्स, ही टॉप विड्थ किती येणार? कोण सांगतंय?
0.7.
0.7.
Very good, 0.7 meter. Okay, for those who don't understand, for them distance from B to C 0.5 meter आहे. आता जर वरती बघितलं डिस्टन्स फ्रॉम F to E तो सुद्धा काय येणार 0.5 मीटर, आणि राहिलेला पोर्शन AF आणि ED it will be, if I add those, it will be 0.7 meter. Now I'll just put here B, C, A, D, E, F. Now here I have got the total head of water, that is 0.3 meter, and I have got the top width. Okay, now for my formula of triangular portion I have to use this formula, 8/15 discharge over a triangular portion, 8/15 CD2, okay, into square root of 2g into tan theta by 2 into काय ना h raised to 5 by 2. ओके, तर इथं आपल्याकडे काय काय आहे, इथं आपल्याकडे कॅपिटल H आहे 0.3 मीटर, CD2 आहे, फॉर ट्रायंगुलर पोर्शन कोएफिशिएंट ऑफ डिस्चार्ज इज 0.6 मीटर्स. ओके, जी आपल्याला माहितच आहे 9.81. आपल्याकडे थीटा बाय 2 ची व्हॅल्यू, थीटाची व्हॅल्यू नाही आपल्याकडे. ओके, so we have to find out the value of theta. Now instead of finding out the value of theta, what if I directly find out the value of tan theta by 2? See, you just have to use your common sense. What to do here? Basically, see, आपण जे प्रॉब्लेम बघितलेला होता, एक साइड काय आहे थीटा बाय 2, दुसरी साइड काय आहे थीटा बाय 2, and if I add both, then I will get this value theta. Okay, so what if I directly find out tan theta by 2? ते कसं करणार मी? Okay, if I just consider the right angle triangle ABF, okay, right angle triangle ABF, okay, so this will be the angle theta by 2, अर्धा angle आहे theta by 2. Now distance from B to F, sorry, B to F किती आहे?
0.3 sir.
0.3. Then distance from A to F काय येणार?
0.35.
0.35.
0.35 येणार. It will be 0.35. Now I know tan of any angle, that means tan of theta by 2 will be opposite side upon adjacent side, that is 0.35 divided by 0.3. So what will be the answer?
1.16.
1.6.
1.1.
1.16.
1.16.
1.16. Okay, so this is the value of tan theta by 2. Directly what I'll do, I'll substitute this value in the formula. Then what is the value of discharge through triangular portion that I get? So what is Q2? Yes. Am I audible?
Yes, sir.
So what is the value of Q2 that you are going to get? Answer क्या है?
0.08.
Yes,
0.081, sir.
0.081.
0.081. So I'll just I'll have to rub here this part. I hope at least you have taken a screenshot or you have written it down in your notebook. So Q2 is 0.081 meter cube per second. Correct? Correct?
Yes.
Is it? Okay. Therefore, total discharge Q will be equal to Q1 plus Q2. What was Q1? Q1 ची व्हॅल्यू किती होती?
0.1504.
0.1504 plus Q2 is 0.081.
0.2314.
0.2314 meter cube per second is the discharge through this trapezoidal notch. Okay. I hope everyone has understood. Is there any doubt, any question?
No, sir.
Okay, I think तुमचं रेक्टँग्युलर
सर tan theta by 2 चं व्हॅल्यू वेगळा आलाय टेक्स्टबुक मध्ये.
हा तेच ना 0.875 आलेला आहे.
हो सर.
बघा कुठं काय जरा चूक झाली असेल. So the total discharge comes around 0.2115 meter cube per second. Okay. Now let's proceed. So here we have finished with the trapezoidal notch or weir. Any questions? Any doubts? Yes. Any questions? अरे हो किंवा नाही काहीतरी बोला.
No, sir.
Discharge. Next is discharge over a stepped notch. So we will see the further type of notch, which is a stepped notch. Okay. Now you don't find stepped weirs. Stepped weirs नसतात त्याच्यामुळं आपण फक्त स्टेप नॉच बघणार आहे, वियर नाही. सो डिस्चार्ज ओव्हर अ स्टेप नॉच. इथं जरा okay, so there is some problem in the title. I will change it and send the corrected notes to you. This is not a trapezoidal notch or weir, it is stepped notch. Okay. So what is a step notch? A step notch is nothing but a combination of rectangular notches as shown in the figure. So if you see the front of the tank or a reservoir, you will see this type of opening in the tank or the reservoir or the channel. Okay, where water is going to fall through this stepped notch. Okay, and the formula for discharge through stepped notch is also very easy, and it is equal to the sum of the discharges through the different rectangular notches. Okay, so as you can see, this stepped notch, which is shown in the image here, it consists of a number of rectangular notches. Okay, so this is notch number 1, this is notch rectangular notch number 2, and this is rectangular notch number 3. Now if we take the addition of discharges through individual rectangular notches, rectangular notch 1, rectangular notch 2, rectangular notch 3, what I'm going to get is I'm going to get the discharge through the stepped notch. So let us see how we can do that. So consider a stepped notch as shown in the figure. Let H1 be the height of water above sill or crest. Sill म्हणजेच काय? Crest. Above crest of notch 1. So H1 is the height of water above the crest of notch 1. Let L1 be the length of the notch 1. So here L1 is the length of notch 1 and H1 is the height of water above the crest of notch 1. Let H2 and L2 be the corresponding values. That means H2 is the height of water above the crest of notch 2. हा जो notch 2 आहे त्याच्या above जो height असेल notch sorry water that is your H2, and L2 is the length of notch 2. Next, let H3 be the height of water above the crest of notch 3. Okay, H3 काय आहे? या notch 3 पासून height, sorry, water level पर्यंतची height, that is your H3. Okay, and L3 is nothing but the length of the notch 3. And CD is the coefficient of discharge for all the notches. आता आपण हे डिफरंट नॉचेस त्याच्यासाठी CD1, CD2, CD3 असं का घेतलं नाही आपण? Because they are all rectangular notches. Okay, and for a particular case all the same types of notches म्हणजे rectangular सगळे notches जर rectangular असतील they will have the same coefficient of discharge. मागच्या trapezoidal notch मध्ये काय होतं? It was a combination of rectangular notch and triangular notch, and the rectangular notch and triangular notch are going to have different coefficient of discharges, but rectangular notches are going to have the same coefficient of discharges. So proceeding, the discharge over notch 1. आता रेक्टँग्युलर नॉच आहे त्याच्यामुळे डिस्चार्ज ओव्हर नॉच 1 काय येणार? लेट अस जस्ट सी 2/3 CD. ओके, L काय येणार? नॉच 1 साठी L काय आहे?
L1 sir.
L1
L1 into square root of 2G into
H1
H1 raised to 3/2. आता डिस्चार्ज ओव्हर द नॉच 2 म्हणजे या नॉच वरती, इथं जे मी रेड लाईनने दाखवलेलं आहे त्या नॉच वरती. So what is going to be the discharge? 2/3 CD आहे तसं. लेंथ काय असणार आहे?
L2
L2
L2 square root of 2G into bracket काय येणार?
H2.
H2
ओके, तुम्हाला काय वाटतं इकडं H2 आलं पाहिजे? ओके, पण आपण काय करणार आहे? सगळ्यांची ऍडिशन घेणार आहे. Q1 plus Q2 plus Q3 that is discharge through first, second and third rectangle notch. मग आता ह्यात प्रॉब्लेम काय येणार? इथं H1 तुम्ही ऑलरेडी Q1 मध्ये कन्सिडर केलेलं आहे. मग परत एकदा एवढी H1 हाईट परत एकदा दुसऱ्या फॉर्म्युल्यामध्ये पण कन्सिडर करणं म्हणजे ते डबल होऊन जाईल. त्यामुळे आपण फक्त काय कन्सिडर करूया? हा जो टोटल सेकंड रेक्टँगल आहे त्याच्या थ्रूच केवढं डिस्चार्ज चाललंय तेवढंच आपण कॅल्क्युलेट करूया. सो इट इज गोइंग टू बी टोटल H2 minus H1 whole raised to 3/2. Discharge through the third rectangle काय येणार? 2/3 CD L3 square root of 2G. आता इथं काय येणार?
H3 minus H2.
करेक्ट. H1 आपण ऑलरेडी कन्सिडर केलेला आहे म्हणजे सॉरी जस्ट लेट मी शो. हा पोर्शन आपण Q1 मध्ये कव्हर केलेला आहे. ओके, Q1 मध्ये हा पोर्शन कव्हर केलेला आहे. आता Q2 काढताना आपण काय केलं? टोटल H2 मधनं H1 मायनस केलं, मग आपल्याला एवढा पोर्शन मिळाला. ओके, आता थर्ड पोर्शन मध्ये आपल्याला फक्त एवढं पाहिजे. ठीक आहे, हा पार्ट पाहिजे आपल्याला. तर काय करणार आपण? H3 टोटल मायनस H2 करणार आपण. H3 मायनस H2 raised to 3/2. and your total discharge through this step notch will be nothing but Q is equal to Q1 plus Q2 plus Q3. Any questions?
सर CD सगळ्यांना सेम असणार का?
हो, सगळ्यांना सेम असणार because they are all rectangular portions. जर तिथं मागच्या वेळी ट्रॅपेझॉइडल मध्ये काय झालं, देर वॉज अ ट्रायंग्युलर पोर्शन अँड देर वॉज अ रेक्टँग्युलर पोर्शन. ओके, आता स्टेप नॉच मध्ये कसं असणार आहे, हे नॉच बिल्ड करायला तुम्ही एक सिंगल मेटल किंवा सिंगल एक मटेरियल यूज करणार आहे आणि सगळ्यांचे शेप सुद्धा सेम आहेत, त्याच्यामुळे कोइफिशियंट ऑफ डिस्चार्ज सुद्धा प्रत्येकाचं सेम असणार आहे. आता कोइफिशियंट ऑफ डिस्चार्ज सेम होण्यासाठी किंवा डिफरंट होण्यासाठी काय लागतं, एक तर शेप डिफरंट असला पाहिजे किंवा मटेरियल डिफरंट यूज केलं पाहिजे. म्हणजे जर मी तुम्हाला तुमच्या समोर दोन डिफरंट रेक्टँग्युलर नॉचेस आणून दाखवले तर त्यांचे कोइफिशियंट ऑफ डिस्चार्ज सेम असतील याची काही गॅरंटी नाहीये. जर त्या दोन डिफरंट रेक्टँग्युलर नॉचेससाठी आपण दोन डिफरंट मटेरियल्स यूज केलेले आहे, एक समजा आयर्न प्लेट आहे, ओके, दुसरा समजा कॉपर प्लेटने आपण ते नॉच तयार केलेला आहे, तर दोघांचे कोइफिशियंट ऑफ डिस्चार्जेस डिफरंट असणार. ओके, सिमिलरली तुमच्या समोर एक मी रेक्टँग्युलर नॉच आणला आणि एक ट्रायंग्युलर नॉच आणला. आता दोघांची शेप डिफरंट आहे, पण दोन्ही काय केले मी आयर्न प्लेट पासून बनवलेले आहेत. तर मटेरियल सेम आहेत पण दोघांचं साईज वेगळं आहे, त्याच्यामुळे दोघांचं कोइफिशियंट ऑफ डिस्चार्ज वेगळं आहे. आता इथं कसं आहे, एक कंटिन्युअस नॉच आहे ही. आता कंटिन्युअस नॉच आहे म्हणजे कुठल्या तरी सिंगल मटेरियल पासूनच बनवली असणार आहे. आयदर इट विल बी अ स्टील प्लेट, अन आयर्न प्लेट, इट विल बी अ कॉपर प्लेट, कारण की नॉच आहे म्हटल्यावर मेटॅलिक प्लेटनी बनवली जाते. ओके, सो आणि शेप सुद्धा सेम आहे, रेक्टँगुलर आहे, सगळ्यांचा शेप सेम आहे, मटेरियल सेम आहे, त्याच्यामुळे त्यांचं कोइफिशियंट ऑफ डिस्चार्ज सुद्धा काय येणार आहे, सेम येणार आहे. आय होप आय हॅव आन्सर्ड युअर क्वेश्चन. येस.
Yes, sir.
ओके, जे आपण फाइंड आउट केले तेच. Therefore, total discharge is equal to total discharge Q is equal to Q1 plus Q2 plus Q3. Okay. Now, if you understood this, let us proceed to the numerical. Step notch is also having only one numerical. One second, I'll just take the attendance of the students. Before we proceed. So this is the numerical on step rectangular notch, and you will be solving this at home. Okay, and this is a very easy question. You can solve it. If you want a discussion on it, we can do the discussion on it in the next lecture, that is tomorrow's lecture, which is going to be at 9 a.m. Okay, so thank you. You can leave
sir.
now. Yes.
Roll number 74 present.
Okay, whatever you want to
Actually,
say.
sir,
Yes.
नेटवर्क एरर की वजह से नहीं आ रहा था सर, मेरे को आवाज ही नहीं आ रहा था. मैंने माइक ऑन किया था.
Okay. Anyone whose attendance has not been put, please reply in the or subject group.
Okay, sir.
Okay, so
Sir, roll number.
no.
Also.
What I said, reply to me in the hydraulics group. I'm ending the lecture here. Thank you, everyone.
Thank you.
Thank you, sir.